Hello, everybody. Welcome to the last video in dealing with projections of solids on the software platform. Here, we're going to deal with a triangular prism of base 40 millimeters and axis 50 millimeters that is freely suspended from one of its top corners, or rather, one of its corners of the top base. Draw its projections when the axis appears to make an angle of 45 degrees to the beat. So, Dr. T. S. Sridhar, when he did his final session on a freely suspended solid, he dealt with a square pyramid and suspended it from one of its base corners. In a pyramid, remember, it's only got one base rather than two bases, meaning that you can only suspend it from one of its base corners in one way, so that the base corner goes up and the axis starts pointing downwards. Whereas in a prism, you've got two bases. And the way you pick it up is extremely important. Here in the question, it asks you to pick up the object or suspend the object from one of its corners of top base. So in order to do that, we need to start the problem in such a way that a corner is easily accessible to be suspended from. Okay, so we're going to start from the top view. First step, as usual, the XY line. And we've been told that the object we're trying to draw is an equilateral triangular prism of base 40 millimeters. So what I'm going to do is draw a line 40 millimeters vertical, then another 40 millimeters, which is at 150 degrees, and another 40 millimeter line, which is at 30 degrees. So all I've got now, all these three lines together give me my equilateral triangle. The reason I'm drawing it this way is to make sure that the top corner here is available to be freely suspended from. Remember, this is a prism, so it means it's got two bases, one at the bottom and one at the top. And as usual, I need to mark where the axis is, and I mark the axis with the help of two medians joined together at a given point. So the question says this is supposed to be 40. Let's check. Yeah, it's at 40. Next, I'm going to draw the axis, which I've been told is 50 millimeters long and vertical. So before I go any further, I'm just going to mark this as my axis, chain link line, 0.5 millimeters thick. And around this, I'm going to recreate the rest of the prism. So me recreating the rest of the prism is actually going to be very straightforward because it's a triangular prism. It's only got three lateral sides or lateral surfaces, and all three lateral surfaces are rectangles. And I finished it. Then you can say whatever stuff you don't need, you can easily trim away. So you trim away this. You can use a trim corner, click on the lines that you need to retain. The others will be trimmed away. So that done, all I've got to do is darken the front view. So, or rather, thicken the front view, 0.5 millimeters. Remember, if it is a square or a rectangular lamina, the center of gravity always lies at the intersection of the diagonals. If it's a triangular or a pentagonal lamina, the center of gravity lies at the intersection of the medians. If it is a triangular, or sorry, if it's any sort of pyramid, the center of gravity is going to lie on the axis at a distance of 1/4 the height from the base. But if it is a prism, the center of gravity is going to lie on the axis at its midpoint. That is what we are trying to mark now. Let's say we are going to suspend the object from this top corner. So what I'm going to do is draw a line from that top corner to the midpoint of the axis. So that's the midpoint. So what I'm going to do is just name a couple of points for convenience. I'm going to call this G dash, G for centroid, and this point, let's say, is A dash. So A dash is the point of suspension, and G dash is the centroid. So for me to consider this problem to be freely suspended, I need to make sure the line A dash, G dash is vertical. So what I'm going to do is use the move command, pick up the object from the point A, just move it somewhere over here so that it's got a certain amount of distance from the XY line. Then use rotate, select the point A dash, select the point G dash and make the line vertical. Sometimes you just have to adjust its space, so that's fine. So this is all you need. So when we look at it like this, obviously to draw the top view of the second stage, you can clearly see that the top base is closer to the observer compared to the bottom base. And that's what we're going to draw first. So this is one vertical projector and a horizontal projector, like so, another one. And this is, remember, always vertical. That's my top base completely visible. Okay, I'm going to do the same for the bottom base as well. Like so. And like that. Okay, also I'm going to try and mark the axis right now. So it'll help me mark it later on. So before we go any further, I need to first mark my base. So the visible base is going to be the top base here, A dash. So from A dash to the other 2 points, I mark the base. Then I mark the boundaries. They go here, 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 and here. Then the longer edges. This basically has resulted in me marking all the longer edges in one go. Okay. So this is A dash, which is, or rather A, which is the point of suspension. Okay. And then G, which is going to be right underneath it. So that's going to be a vertical line in the front view. In the top view, it is going to appear as if it is a single point. Okay. The only thing I need to mark now is the axis, which is from A to the end of the axis line, and I'm going to mark it as the axis line. So my next question is, or rather the next portion of the question is, that the axis appears to make an angle of 45 degrees to the vertical plane. So all I need to do is, just like the previous problem, I'm going to select the whole thing, okay, and then I'm going to move it to the next stage, let's show, and then rotate. In the previous problem, if you remember, we rotated in such a way that the base was perfectly visible. So what I'm going to do here is I'm going to rotate it in such a way that the base is not visible. So I select the moved object, I rotate it to 45 degrees. I rotate it like that. So if the question says the base is away from the observer, you move it like this. Okay, I'm going to just make a few changes so that you understand what is what. So there's an option for you guys to fill in or shade a given region. So I'm just going to use that to illustrate my point. Okay, so this shaded region is the top base, the base in orange. Let's say I pick up green. So the green base is my bottom base. Okay, and remember, the bottom base is placed in such a way that this edge here is the edge on which the object is resting, which means that it is an invisible edge. So if that invisible edge is the edge on which the object is resting, that is going to be your reference for whether the base is closer to the observer or away from the observer. Let's say the question says the edge on which the object is resting is closer to the observer. Basically, closer to the observer means that it has to be rotated like so. Okay, if the question says the base is away from the observer, you rotate it like that. Okay, sometimes it might be confusing to figure out which is closer to the observer and which is not. General rule of thumb is If the object is, if the question says closer to the observer, you rotate it away from the XY line. If the object says away from the observer, you rotate it closer to the XY line. So let's say the question says the base edge is away from the observer. So that means the top base is closer to the observer. So we rotate it like this at 45 degrees. Let's base it. So the top base is now closer to the observer. And that is where we start our projections from. So there, okay, again, be careful and ensure that line thicknesses are maintained whenever you draw the projected lines. They have to be thin. So that's my top base identified. Next, I mark the bottom base. Remember, the bottom base is over here. It's not going to touch the XY line or HP purely because the object has been freely suspended. The other end, it's here. They have to be either horizontal lines from the front view and vertical lines from the top view. If they are not, you are definitely going to make a mess of it somewhere or the other. Okay. So yeah, to mark the axis line, I'm just going to hide the shaded portions I've done earlier, or take it away. The axis line is here. And the other axis, end of the axis would be roughly there. Okay. So all I've got to do now, we'll worry about the axis later. All I've got to do now is mark the visible base, which is up here. Like so. Then the boundaries. Like so, and then the longer edges. That basically has completed your particular sketch. So this, let's go back to our orange colors. So this is our top base up here, and this is our bottom base. So all I need to do now is mark the axis. Starts here. Make sure the line thicknesses are correct. The horizontal line for the axis is down there. So the axis is going to start from this point and end at that. So I'm just going to trim away the stuff that I do not need, and I'm going to mark the axis as a chain link line like that. So this is how your problem should look like. Okay, as I said earlier, and something that some teachers actually recommend against is changing colors. Obviously, you won't be able to do this on a drawing sheet. It's only restricted to you guys doing this on computer. So changing the color of your projector lines, your XY line, okay, not the XY line, change projector lines and the construction lines and the like to gray basically makes the sketch pop out much better. So let's say I just make this gray. This is what your problems should look like. In an example, not necessarily gray, what I meant was that the sketches you've drawn, the objects, the solids, the planes should be distinct from the projector lines and the construction lines. Okay. Obviously, I have skipped naming all the points here just because I'm comfortable. That doesn't mean you can do the same thing. So make sure you give enough time to name all the points. Okay, so that's basically it. I know this is a slightly longer video than the last one. I had planned for the previous video to be the last one, but somehow it didn't work out. So This basically completes your chapter on projection of solids in computer-aided engineering drawing. Talk to your teachers if you have doubts. Make sure you get them solved as soon as possible. Okay, keep in touch with your teachers through Google Classroom, call them, text them, because they will be sending you problem sheets, they'll be sending you these videos, they'll be sending you model question papers, a lot of things, so that you guys are better prepared for the exams. Okay, thank you very much, everybody. Take care. I'll see you when you guys are back in college.